Okay, I haven't had a chance to check it. I think this is right though. The first part of the question is frequency against root t, and the second part of the question, and I think, is an investigation of frequency against 1 over length. So for me to rearrange it then, I'd have 1 over length on the x-axis, frequency on the y-axis. So f equals open bracket a half root t over mu, close bracket 1 over L. It's in the form y is equal to mx, so the thing in brackets is the slope. Now if we square then, this is on the bottom right hand side, second last line, if we squared both sides to get rid of the square root, you'd have m squared as 1 over 4 t over mu, rearranging mu is equal to that. Okay, if that, I'll check that later, but if that's not right, I'll come back to it. Okay, the next two pre-questions, check if they're useful to you. If not this video, you don't have to worry about it. So 2019 question 10. Sorry, I'm starting with 2020 question 6 actually. So definition of Newton's second law, F is proportional to mv minus mu over t, and the notation is required. Now we need to derive F is equal to ma from that. So if the mass is the same before and after the impact or interaction takes place, we can take that out as a common factor. That's on the right hand side, first line. Took out the m. V minus u over t is a. To go from proportionality to equals, we need to introduce a constant of proportionality. That technically is the slope of the line, where f would be on the y-axis and m by a could be the x-axis values. And then for SI units, the k value is equal to 1, so we just get f is equal to ma. Okay, next part. It's describe an experiment to be able to find the resultant of two forces. So what you need is 3 Newton balances. They're all connected. They're stretched or taut. And it's done so that the point A, which is the joining point between the 3 Newton balances, is at rest. If that's at rest, there's no net force acting on it. So the resultant of any two of those forces would be equal and opposite to the third. And that's what I have there with the arrow. The arrow means that's equivalent to F1 plus F2. So the force F1 plus F2, if you added the two of those vectors, it would be equal and opposite to F3, which is why we've minus F3, because it's opposite direction to F3. And then your conclusion, or how you would do it, is you just read the value for F3 to find the resultant of the other two forces. I've simplified that experiment as well a lot, in that my F3 is horizontal. And what that would mean then is the vertical component of F1 and the vertical component of F2 are equal and opposite, so the horizontal components only are, the horizontal components of F1 and F2 would equal F3 there as well. Okay, the next part, the cricket player catches the ball and slows the ball down by increasing the time that the ball is in contact with their hands. And you're asked to explain with Newton's 3 laws what they're actually doing. Now I've given a pretty detailed answer there. In the Leaving Cert, you would want to have something as detailed as that. So first of all, the ball will continue to move unless a force acts upon it. So the player needs to be acting a force upon the ball. That's Newton's first law. 2. F is proportional to mv minus mu over t. You were asked to define that at the start, so this one is actually really important to put into the answer. If I cross multiply by the t, I get ft is proportional to mv minus mu. If I use SI units, I get f by t equals mv minus mu. In other words, the force multiplied by the time is equal to the change in momentum. And what we want to do is we want to change the ball's momentum from moving to 0, essentially. And the way to do that is to have a force acting on the ball by a particular time. So the force has to be acting on the ball over a particular length of time. That's why you've got F by T on the left-hand side. So when she catches the ball is in contact with her hands for a long time. And the force that she is acting on the ball multiplied by that time will lead to the change in momentum, which is why I've mentioned Ft is equal to mv minus mu. And that's what I'm saying in the second part. We're using Newton's second law to say that the longer she remains in contact with the ball, the less force she needs to change the momentum per second. Okay, and then the third part, according to Newton's third law, if she exerts a force on the ball exerts a force on her. So if she exerts that small force that I talked about previously over a longer time, she feels a smaller force over a longer time as well, and it has less of an effect on her then. In other words, she just cushions the ball to rest in her hand. Okay, the last part. I would have thought that was actually an applied maths question, but this is the second time I've seen such a question in a couple of years, so I'll have to go over this stuff with you. You basically have a person who's thrown a ball. They're at a height of 1.6 meters when they throw it. Someone catches it at 1.6 as well. So basically it's like the ball is fired from the ground and lands on the ground. So we can ignore any height difference there. And we're asked for the time the ball is in flight. The key here with these questions is to understand that the vertical motion of the ball can be separated from the horizontal motion of the ball. So we look at the vertical motion of the ball, and what I have is a diagram with an arrow to the top right hand side with 28 over it, and then the angle is 45. So what I've done is I've resolved that velocity even into its vertical component only for the time being, which is 28 sine 45. And then if I look at S is ut plus a half at squared in just the vertical direction, when it lands, the ball lands at the same height with which it was thrown. So the vertical height is actually equal to 0, so S of y is equal to 0. The u is the speed, but it's the speed in the vertical direction, which was 28 sine 45, which is the same as 28 over root 2 by t, minus a half of g, which is 4.9 by t squared. You can just solve for t then, and that will give you the time of flight, or the time the ball is in the air. The next part of the question asks for the horizontal distance. So now you have to look at everything horizontally. And looking at it horizontally, you need a speed horizontally, you need an acceleration horizontally. We know the time from the previous bit, and we're looking for the distance travelled. So if you look at the section that says horizontal distance, examine horizontally, just below that, S of x equals u of xt plus a half by 0t. Acceleration only acts vertically, so there's no acceleration horizontally, so that term drops out. U of x will be the horizontal arrow in my diagram on the right hand side. That doesn't have anything, no numbers below it, but that's actually 28 past 45 when you work it out. Multiply by the previous time, and that will give you the horizontal distance. Okay, the next part, the maximum height. For the maximum height, we're talking heights, so we're looking at the ball vertically again. And what you need to understand is when the ball reaches the maximum height, it stops moving. So its velocity in the y direction equals 0. Fill that into v is equal to u plus at. Again, it's the velocity in the y direction, so it's 28 sine 45. Acceleration in the y direction is downwards. We're throwing it up, so it's minus g, minus 9.8. And you should be able to solve for t in that case. And on the left-hand side, the bottom left-hand side, you have the diagram that shows v is equal to 0. The force acting on it is a force downwards of F, which is equal to mg, its weight, and the acceleration is just equal to g downwards. And that was quite a lot. So if you need to pause the video until we go on to the next one, work ahead, but I'm going to keep going. Right, 2019, question 10. I have a feeling that this isn't the part that somebody wanted me to do. They just gave me the question. So I need to go through this just in case you haven't got it, but I'd ask you to be a bit more specific in future. Do you want me to do all the question or just a particular part of it? Because it'll make these videos shorter for you. All right, part 1, define the two of them. You should be able to find the definitions yourself. Part 2 is Young's slits experiment, and you're asked to outline Young's double slit experiment and describe how it shows that light is a wave. So on the left hand side, I've got a light wave. I've just drawn the crests of the wave there, and there are two slits, S1 and S2. So the light hits the slits, and then diffraction occurs at both of the slits. Those slits have the same frequency, so they're coherent sources. And then on the right hand side of the slits, interference occurs, and you see positions of constructive and destructive interference, which are bright positions and dark positions respectively. That's the experiment outlined. And then it shows that light travels as a wave because light undergoes both diffraction and interference. Okay. Calculation section. So in the calculation section, you're told that in Young's double slits, the distance between the slits was 0.5 millimeters. So that means the d value that goes into the formula n lambda as d sine theta is 0.5 by 10 to the minus 3. The distance between the slits is the d value. Then you're told that there are 13 slits in total. That means you're going to have 6 above the 0 position and 6 below. So we're looking at n equals 6 to fill into our formula. And you're told two other things. The distance from the screen to Young's double slits is 1.25 meters. So I've got a little triangle there with theta and 1.25 meters on it. And the distance between the 13 orders was 1.65 centimeters, I think, something like that. So I had to half that to get the distance between the 0th order and the 6th order on top. And that's what I have on the right hand side. I've also converted it to centimeters, which is why I've got by 10 to the minus 2. So if you got the inverse tan of that, inverse tan of theta is equal to the opposite over the adjacent. That would give it the angle, and you can fill the angle into n lambdas d sine theta. And I've done that all in the second step. You just need to work it out. Next part, what adjustments to increase the distance between the constructive interference? Decrease the distance between the slits or increase the wavelength. Okay, next part, we were talking about a lens. A thin lens has very little refraction power. So that means the focal length is small, so the power, the power is quite small. It doesn't refract it very much. The two diagrams for the fundamental frequency and the first multiple of the fundamental frequency are shown, and you're given two lengths for each of those, and you're asked to work out the speed of sound. You're given the frequency of 512, and if you look at the two diagrams for f and 2f, if I was to subtract the two of the distances given there, it would give me half a wavelength. And that's what I did. So on the right hand side, L2 minus L1 is half a wavelength. That's 0.331, double it. 0.662 is the wavelength, multiplied by the frequency, and that's 512.